When installing a generator and transfer switch, proper grounding and bonding are critical for safety and code compliance. The key principle to remember is that the neutral and ground should only be bonded together at the main panel or at the transfer switch if it's designed to be a service entrance when operating on generator power. Let's break down the correct wiring procedure. Firstly, it's important to understand the function of the equipment grounding conductor, often a bare or green wire. This conductor connects to the ground bar in your electrical panels and to the green grounding screws in electrical boxes. Its purpose is to provide a low impedance path for fault current to return to the source, allowing overcurrent protective devices like circuit breakers to trip and clear the fault. If your generator is a non-separately derived system or non-SDS, it will not have a neutral to ground bond within the generator itself. In this scenario, the transfer switch becomes the location where the neutral and ground may need to be bonded, depending on its design and whether it is switching the neutral. Let's discuss the subpanel wiring in more detail. The subpanel receives two hot wires and a neutral from the transfer switch. The neutral conductor from the transfer switch must be connected to the neutral bar within the subpanel. All of the load neutrals, meaning the neutral wires from the individual circuits in your home, should also be connected to the same neutral bar. It is very important that you do not bond the neutral bar to the subpanel enclosure in this specific scenario, as that would create an unintended neutral to ground bond. Now let's consider the grounding conductor. The equipment grounding conductor originating from the main panel must be connected to the ground bar in the subpanel. The conduit system alone is not sufficient to serve as the only grounding path. A dedicated equipment grounding conductor is required for safety. The connection of the equipment grounding conductor ensures a reliable low impedance path for fault current. Furthermore, a bonding jumper might be required from the ground bar to the neutral bar connected to the transfer switch feed within the subpanel, depending on the type of transfer switch. This ensures that the neutral and ground are properly bonded at the transfer switch location, as intended. It is very important to check the manufacturer's specifications to verify if a bonding jumper is indeed required. Now let's address the question of the conduit system. While a metallic conduit system can contribute to the overall grounding system, it cannot be relied upon as the sole means of providing the equipment grounding path. The equipment grounding conductor, whether it's a wire run inside the conduit or the metallic conduit itself when properly installed according to code, is essential. The NEC requires a dedicated equipment grounding conductor for safety. The proper installation of grounding and bonding systems is described in Article 250 of the NEC. Grounding electrode systems, the size of grounding and bonding conductors, and acceptable methods for connecting to ground are also detailed in the NEC. It is also important to consult with a qualified electrician who is familiar with local codes and regulations. They can assess the specific details of your installation and ensure that it is safe and compliant. In summary, the correct procedure involves connecting the neutral from the transfer switch to the neutral bar in the subpanel. Then connect all load neutrals to that same neutral bar. Connect the equipment grounding conductor from the main panel to the ground bar in the subpanel. Depending on the transfer switch type, bond the ground bar to the neutral bar connected to the transfer switch feed. This ensures proper grounding and bonding and maintains a safe electrical system. Always consult with a qualified electrician for any electrical work, especially when dealing with generators and transfer switches. They can ensure that the installation meets all applicable codes and regulations and that your electrical system is safe and reliable. It is important to understand that electrical codes and best practices can change. Therefore, it is necessary to review the latest edition of the NEC or other applicable electrical codes before performing any electrical work. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. The importance of proper grounding and bonding cannot be overstated. These practices are essential for protecting people and property from electrical hazards. By following the guidelines outlined above and consulting with a qualified electrician, you can ensure that your generator and transfer switch are installed safely and correctly. Always prioritize safety when working with electricity. If you are not comfortable working with electrical systems, it is best to leave the work to a qualified professional. Remember to turn off the power at the main panel before working on any electrical circuit. Use properly insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. By taking these precautions, you can minimize the risk of electrical shock and injury. Understanding the role of the transfer switch is also crucial. A transfer switch allows you to safely switch between utility power and generator power. It prevents backfeeding, which is the dangerous situation where generator power is sent back into the utility grid. Backfeeding can energize power lines, creating a hazard for utility workers and others. There are two main types of transfer switches: manual and automatic. A manual transfer switch requires you to manually switch between utility power and generator power. An automatic transfer switch automatically switches to generator power when it detects a power outage. The choice of transfer switch depends on your needs and preferences. An automatic transfer switch provides greater convenience, but it is also more expensive. A manual transfer switch is more affordable, but it requires you to be present to switch between power sources. Regardless of the type of transfer switch you choose, it is important to have it installed by a qualified electrician. They can ensure that the transfer switch is properly wired and grounded, and that it meets all applicable codes and regulations. When selecting a generator, it is important to choose one that is appropriately sized for your needs. A generator that is too small will not be able to power all of your essential appliances. A generator that is too large will be more expensive to purchase and operate. To determine the appropriate size generator for your home, you need to calculate the total wattage of all the appliances and devices you want to power simultaneously. Add up the wattage of all the items you want to run at the same time. It is important to consider the starting wattage of certain appliances, such as air conditioners and refrigerators. These appliances require more power to start than they do to run continuously. Once you have calculated the total wattage, you can choose a generator that is slightly larger than that amount. This will ensure that the generator can handle the load without being overloaded. Also, make sure to consider the fuel type of the generator. Generators are available in gasoline, propane, and natural gas models. Gasoline generators are the most common, but they require you to store gasoline on site. Propane generators are cleaner burning than gasoline generators, and they can be connected to your home's propane tank. Natural gas generators are the most convenient, as they can be connected directly to your home's natural gas line. However, natural gas generators are also the most expensive. The location where you install the generator is also important. Generators should be located in a well-ventilated area away from windows and doors. This will prevent carbon monoxide from entering your home. Never operate a generator indoors or in an enclosed space. Carbon monoxide is a deadly gas that can be produced by generators. It is odorless and colorless, so it is important to have a carbon monoxide detector in your home. Regularly inspect and maintain your generator to ensure that it is operating safely and efficiently. Check the oil level, air filter, and spark plugs. Change the oil and air filter regularly according to the manufacturer's instructions. Store gasoline safely in approved containers away from heat and sparks. By following these tips, you can ensure that your generator is ready to provide power when you need it. The electrical system in your home is a complex and potentially dangerous system. It is important to have a basic understanding of how it works and to take precautions to prevent electrical hazards. Always consult with a qualified electrician for any electrical work. They can provide you with expert advice and ensure that your electrical system is safe and compliant. Remember that electricity can be dangerous, so always take precautions to protect yourself and your family. Follow the guidelines outlined above and consult with a qualified electrician to ensure that your generator and transfer switch are installed safely and correctly. Stay safe when using electricity.